Hello, good evening. My name is Yogendra Kumar. I'm a maths teacher at askIITians. Okay, so we are going to do today. We are going to start lecture number 2 of number systems, ninth grade, right? And as we talked about it last class, also that this chapter has weightage of 8 marks in your full chapter, like a full syllabus test. Okay, when it will happen, okay, so it comes out of 100 marks, you can count this chapter for 8 marks, right? So that's why it is really important chapter. Okay, we need to learn in detail, and you need to understand the importance here of the this chapter, as because we are going to deal with the numbers in all other chapters. So this is that way it is really important chapter. We need to talk about different types of numbers, like last class we discussed about it. So I want to just give brief intro of last class, also brief of last class, what we have done in the last lecture. So it was like we discussed about numbers. Okay, so we talked about numbers, real numbers. As I told you that real numbers are all the numbers which we study is what, okay, those all are counted as real numbers. Now real numbers can be divided into two uh, parts. Okay, they are like real numbers can be divided into uh, my bad, 1 second, it's something wrong with pen. Okay, yes, yeah. Okay, so real numbers can be divided into two categories. First one is what, rational number, and then what is the other category? Irrational number, right? Which is shown here also. This is also it is shown here, but I wanted to just confirm that real numbers are right? Like real numbers are what? Rational plus irrational. Okay, those all are like in the like in the mathematics. Okay, whatever numbers we are talking about, those are either rational or irrational. Okay, so these are rational number and irrational number, like that you can see. Irrational numbers are what, like examples are given here: pi, e, root 2, and this decimal form also, right, which is non-terminating but recurring, non-recurring. 1 2 1 1 2 1 1 2, like this it keep on, it's not repeating. Okay, but rational numbers are what? These are whole numbers, natural numbers, integers. Okay, all these numbers, natural numbers, whole numbers, integers. Okay, fractional numbers, right? And especially I want to talk about this form, which is what, like 1 4 1 4 1 4, right? 1 4 1 4 1 4, like that it continues. So what is this? Non-terminating, because this is what most confusing. Okay, so that's why I want to point out this properly: non-terminating and non-recurring. Non-terminating, non-recurring. But this one is what? Non-terminating, non-terminating and recurring one. Okay, my bad. Okay, 1 second, I want to clarify here. Okay, 1 point. Okay, this is recurring. As you can see, it is repeating 1 4 1 4 1 4. My bad. Okay, so please correct it. Okay, I know I made a mistake there. Okay, so I want to apologize for that. Okay, this is what, non-recurring. This one is what, non-recurring. I hope you're understanding this. This is what, non-recurring. So this one is recurring, means repeating. Recurring meaning is what? Repeating. So if you want, instead of recurring, you can use the word repeating also here. Okay, I'm not able to write it. Okay, let me write down here. Repeating. This is repeating one, and this is what? Non-repeating. Non-repeating. So this is what, which because it is not available in this picture, so that's why you need to point out this clearly. Okay, so this is what we have seen. Now after that we have seen decimal forms, like representation on the number line. We talked about number line, and then we have seen their its representation on the number line, right? So now, okay, we have seen for rational numbers, but for irrational numbers we have not seen the, like, I didn't discuss about the representation on the number line. So that is what I want to do this class. I know these are the topics for this class, but we as this was left out, so let me complete that also here, and that way we will be like, after that we will be continuing further to this. So this is what the main thing we talked about it. Okay, we are going to see now next after that, okay, real numbers and their decimal expansions, computing fractions from decimals, okay, proving irrationality, okay, like irrationality, right? How root 2 is irrational, okay, we want to prove that, right? So that's what we need to remember, the definition of rational numbers. Okay, we as I gave you the definition of rational numbers last class. So let's continue further, right? That is what we need to discuss. Okay, so I would be requiring some space to, okay, let me add the page here, guys. Okay, 1 minute. Keep the annotation. Okay, okay, so let's do it here. We want to show okay, so as we have seen last class, okay, representation, like locating what should be the topic name here? Okay, locating irrational numbers on the number line. That is what I want to cover in this chapter. Okay, locating, I want to cover here first. Okay, this one, locating irrational numbers on the number line. Okay, this is what we want to see here. So what do we say? Okay, number line is there again, as we talked about it last class. Number line is there, and it is starting with 0 here, 1, then 2, then 3, then -1, -2, -3, -4, -5. You know that we keep negative numbers this side and positive number this side. Till where it goes, plus infinity, we say like it is very big number, and minus infinity, right? This is what 0. So we want to see the behavior here, okay, and we want to locate the numbers like that. So suppose we want to locate, okay, question is what here? Locate root 2 on the number line, right? So what we do here, for root 2, I know that it is what 1 point something and all, okay, but we are not interested in that. We want to do it like we want to do it, okay, on the this location here, exactly where it will come, right? That is what we want to see. So can I write down root 2 can be written as 1 plus 1, 1 plus 1, and I can say 1 square plus 1 square. Now if you look at it, okay, like it looks like, you know, Pythagoras equation, right? Pythagoras equation, we know in a triangle, because basically idea is coming from there. Okay, in a triangle, when this is 1, this is 1, so it will be like 1 square plus 1 square by Pythagoras. I hope you all know this, right? If you, by chance, if any doubt is there in this also, you can clarify with the teacher. Okay, right? Okay, and you can come back to this lecture, and then you can get the clarification on this, and then you can do it. Okay, so this is what Pythagoras theorem, right? So Pythagoras theorem, using Pythagoras theorem, I can see that it is what looks like pair of two numbers whose square is giving like this, okay, root form like that. Okay, so this is what, okay, like if it is a b c, so a b square plus b c square is equals to ac square. So ac can be written as ab square plus bc square and root over of this. So that's how. So can I say here, if I go, now you have to pay attention to this, okay, here, that if I go from this 0 1 unit here this side, okay, 1 unit, and this is my point, okay, I can say this is what a point, this but b point, you can mark it as o also, but it is 0, okay, 0 point. Then I want to go at 90-degree. Using compass you can make it 90-degree, and you can go 1 unit here, 1 unit, 1 unit here, and 1 unit above, right? And this is what 90-degree here. So I think you can understand, like it will act as hypotenuse here, right? This is what hypotenuse here, which is what going to give you root 2. Now what will you do? Like you will keep the compass here and you will take the measurement till here and you will make an arc like this downward, right? We'll make an arc like this. So this is what, okay guys, this point where it is cutting here, that is what are, how much is this? Root 2. And if you know root 2 decimal form, okay, it is what, 1.41 something, right? So this is coming like exactly in between 1 and 2, not exactly at the middle, it should be little behind. Okay, if you do it accurately, I think you will get it. Okay, so what is the idea we are using to locate root 2 exactly where on the number line, right? So this is what, okay, this is what we needed, right? This is what we got here. So that is what root 2 location exactly. Now if someone says, okay, I want to not root 2, I want to do for root 3, let's say. So how we will do for that? Root 3 can be written as 2 plus 1, and this is root 2 square plus 1 square, root 2 square plus 1 square, this. So now I'll take the help of this root 2 here. I can take the help of this root 2 here, and I can make further to this. Or another way is what, like, okay, you have root 2 here, first make root 2, then 1 unit above here, because in root 2 we want to add 1 unit more, right? 1 unit here, and then you can get root 3, right? I think it makes sense. Okay, or you can make here also, how much, 1 unit. So now this is what, okay, this is what we have, root 3, and now you do this, okay, like this. Okay, like this it will be coming. Okay, I know, like I am doing a little bit here, okay, like this in here, but I hope you're understanding the method, right? Suppose I have root 5. Root 5, what we will do, you can take 2 square plus 1 square, right? Two numbers I can bring, because 2 square is what, 4 plus 1, so that's why, like this I can make the Pythagorean triplet or Pythagoras equation I can utilize here. So now what you do here, let me take another number line, 0 here, then 1 unit here, 2 unit here, and then 3 will be there here, right? So I should take 2 unit here, because 2 square is there, and then 1 unit above here, 1 unit, right? Now I think you know that how much is this, how much is this exactly? This is what, root 5, because it is nothing but 2 square plus 1 square, right? Now if you need to make the arc, you need to make the arc, which will be like this, right? So that is going to be almost 2.3. This is how we are going to locate the numbers on irrational numbers on the number line. I believe it makes sense. Okay, right? This is how we are going to do it. Okay, you can do for bigger numbers also, right? Suppose root 17 is there, So what will you do? Root 17 is what? 4 square plus 1 square, right? So 4 unit and then 1 unit we can make. Okay, you can have for, okay, root 7. How we will do root 7? So you can do here 4 plus 3 is what? Root 7. So you need to make root 3 square plus 2 square, right? Like that you can make. Okay, this is how you are going to show, you can make break down every number, right? Like that. So this is how we are going to represent irrational numbers on the number line. I hope it is clear. Okay, now let's come to topics, okay, which are like real numbers and their decimal expansions. I think we talked about it last class also, but no problem, we can repeat again. Rational numbers and irrational numbers can be differentiated on the basis of their decimal expansion, right? So what is the differentiation? What is the difference between the two of these forms? Okay, what is the basic difference? So what we do here, okay, when we divide p by q using long division method, either the remainder becomes 0 or remainder never becomes 0. We can get repeating string of numbers, right? We can get repeating string of uh, remainders, right? So like this, okay, if I divide, okay, 5 divided by 11, 5 divided by 11, what we are getting? We are getting 0.45, 0.45454545. It will keep on repeating. You can see this example when we do long division. So it is what type of form is there? This one, it is what, as I discussed before, non-terminating recurring. Recurring means repeating. Non-terminating recurring. Okay, this is also non-terminating recurring. So whenever the non-terminating form is recurring, it is rational number. If non-terminating form is non-recurring, means it is not repeating itself, then that is what? That decimal form is what? Irrational number. As simple as it is. I hope you are getting the idea. So 1 by 2, 0.5, 7 by 5, 1.5. Wait, I think there is a mistake here. It has to be 1.4. Right? How it is? Okay, let me show you. This one here, 1 by 2. We can do long division also, like, and without long division also. I showed you the method, okay, last class. 5 divided by 10, which is what? 0.5. Now similarly, this other one, 7 by 5. Can I multiply 2 and 2 up and down? So it is 14 divided by 10. So it is 1.4 clearly, right? And for negative number, like this, what we'll do? Minus 8 divided by 25. Minus 8 divided by 25. So what it will be? Minus 8, 5 into 5. So we need to multiply 2, 2 here, 2, and 2 here. What we get here? 32. Minus 32 divided by 100. So what it is? Minus 0.32. Right. So this is how we are going to do these numbers, right? So that's what the main idea. Like we can we will obtain for a number which is what, non-terminating recurring. That is what irrational number. Sorry, that is what rational number. Sorry. Okay. So 1 by 2, which is what? A rational number. Its decimal form is going to be terminating. If it is non-terminating, then it has to be what? Repeating. That's what. This is what we need to remember. Okay. So express the following rational numbers as decimal numbers. Okay, we can do this question here. Okay, so we can do two ways here. We have taken the example last class also, but let's do it today as well. No problem. I can do long division. Two methods are there. For this one, for this, but for down one we have one method only, but for this one we have two methods. Okay, one is what? Long division. 7 has to be divided by 7 has to be divided by what? We need to divide it by the 25. Okay, so we'll put point and 0 here. So 25 2 times. Okay, it will be 50. Then what we got? 0 2. Now again this one here. So what it is? 8 times it will go, and 200. So we got 0. So 0.28. We are getting the answer 0.28. Or what is the other method? 5 into 5. 25 can be written as 5 into 5. Now what else I need to multiply here? I need to multiply 4. Yeah, 4 I can multiply up and down. What happened by 4? Okay, 25 into 4, it will be 100, right? So 28 divided by 100, which is nothing but 0.28, right? This is simple. Now this example, okay, 47 and 99.0. So how many times it will go? 4 times 396. Now 4 here, and then here 4 here, and here 7, right? So now again 0. How many times it will go? 7. So what we can see 3 6 what are we going to get when I do 7 times here? 693. So what is the remainder I'm getting here? 7 and then 4 here. So again, how many times we can do? 4, then 396, then 74, 0 here. So 7. So it keeps on repeating, right? It keeps on repeating. So you can see it is what? Non-terminating and recurring. 0.47 repeating. 4 7 both are repeating. That's why we are kind of making this notation on both. Okay, that they might be repeating. In few books they might write this way also, so don't get confused. This also in very few books, okay, like that it means what? 4 and 7 both are repeating, like that. But generally it will be like bar over it, okay, like this. So that is what the representation. So what do we say again? Okay, now without doing long division, how can I identify? Now question might be here, without doing long division, how can I verify it is going to be repeating, it is going to be terminating or non-terminating form without doing long division? So we can write a note here, and it is very, very important note. If denominator of rational number is of the form 2 raised to m and 5 raised to n, means in the denominator we have 2 or 5 or both, and no other number is there, apart from this 2 or 5, right? Then it's going to be okay, what it is going to be terminating. It is going to be what? Terminating. Going to be terminating decimal form. Okay, but if it is not, then it is otherwise it is non-terminating, because it is rational number, so it is non-terminating recurring, or you can say repeating. Non-terminating, recurring, or repeating form it is, right? This would very important note you can write down. Without doing long division, we can identify whether it is terminating or non-terminating, right? So only we need to check the denominator of the number. So these are what the answers. Okay, you can ignore this, right? I hope it makes sense. Right. So this we have seen last class also, I believe. Okay, this thing that what repeating, non-repeating, irrational, right? Correct. It makes sense, right? I hope it is clear. You can, without doing long division, how to verify. That is also clear to everyone. Now we come to this part. Okay, computing fractions from decimal form. Write down the decimal divided by 1, like decimal divided by 1. Multiply both top and bottom by 10 for every number after decimal. Okay, like this. I believe you're understanding. Suppose fractions we need to obtain from the decimal form. So like 0.15, like this example is there. What is there in the denominator? 1, right? What we say every time we have the number 1. So we can multiply. How many digits are there? 2 digits. So we should multiply up and down by 100. So we get 15 divided by 100. Now we can divide the numerator and denominator by what number we can divide? We can divide by 5. 5 3 times and 5 2 0. Is that clear? So 3 divided by 20 is what we have, 0.25. This is what? So this was what was given to us? 0.15. So we got from decimal to fractional form, right? Decimal to fractional form. Okay, we need to simplify, right? That is the last step. We should not leave the answer like 15 by 100. We want to give the answer on the simplified form always. Yes, right. This is what, okay, it is showed. We can take different example also of course, okay, and you can do this same way. So suppose this question is there, convert 2.35 to fractional form, right? So 2.35 is there, right? Now what 2.35 divided by what do I have in the denominator? 1, right? Now what should I multiply up and down? Because 2 digits are there after the point, so that's why we should multiply by 100. So we got 235 divided by 100. And now let's simplify it. Let's make it a simplified fraction, right? So 5 fours are and 5 sevens are, right? 5 fours are 20, then 3 is left out, 5 sevens are now here down 20. So 47 divided by this. This is what we got, right? This is what, okay, there is no need of this one. Okay, like 47 by 20 is what our final answer. Yes, we can take more examples. Okay, there is if it is just 2 digits, okay, if we have like 2.3 only, example, another example. So 2.3 divided by 1. Now how many digits are there? Only 1 digit, so that's why 10 10. So 23 divided by 10. Now we can't simplify, so leave it as it is, right? Now we can have more numbers. Okay, another example like 1.25. 1.25. Now what is there in the denominator? 1. 1.25 divided by 1. So now, okay, we need to multiply 100 and 100. So 125 divided by 100. Now again by 5. 5 twos are and 5 fives are, then 5. Okay, one more time it can go 5 and what, 4. So 5 divided by 4, right? Now suppose, okay, we have example, another example I'm taking 0.125. So again, what is their denominator? Okay, we have denominator as 1. Now let's multiply. What we can multiply up and down? We can multiply by 3 digits are there, so 1000 we should multiply, right? Now, okay, we got 1000, so what will be written here? 125 divided by 1000. Now it can go by 5, right? We can, or if you want, if you know 25 times, it is what, 5 times, and then 25 fours are. And again, right, we can simplify there, 1 by 8. This is what the answer we got, 1 by 8, right? So this way, I think you got the idea that decimal form to fractional form is not that difficult. You can bring it always like this, right? So we should know the interconversion from decimal form to fraction form and fraction form to decimal form, because we will be requiring both the forms. We need to remember both the forms, like how do we do the interconversion, and it is like going to be a very basic thing going forward in the maths, right? So that is what we have here. Okay, let's move on to next. Okay, they're explaining here all these points which we discussed before, right? I hope we got the answer for first one. Oh, okay, I can understand that answer is coming different because here they are taking our question. Original question was 2.35, but by mistake it is taken just 0.35, right? So 0.35 they're taking. So I think it is not the solution for the previous question. I need to change. Question is 0.35 to fractional form. 0.35 we need to write in the fractional form. So 0.35, okay, you can understand 35 divided by 1 into 100 here. So 35 divided by 100. Now we can divide here by 5 here. 5 sevens are now 27 by 20. That's what the answer here. Right? That's what. Bring back 2 to mixed fraction. Okay. Okay. Very good. So basically, we did for this. Okay, this one here. Basically, we have done for 0.25. Now, it was original question was what? Okay, this is another way we can say, like okay. So if I add, you can understand here. If I add 2 plus 7 by 20, what we will get, guys, here? What it will be? Okay, will I get, okay, what it is, 47 divided by 20, and which is nothing but 2 point, which is how much? 2.35, right? So it is not like, okay, you can say it is what, plus here. Okay, if you want, okay, it is what, plus here, not this here. Okay, like this, it has to be plus here. That's what they wanted to do, but it is not bring back the 2 to the mixed fraction. So that number which was there, original question was, I hope the doubt is what clear. Original question was 2.35. So we can write 2.35 as 2 plus 0.35, and you do for 3.35 separately and add the 2 back. Okay, so that's what it is, 2 plus, or it is actually they mean to say, I know there is no mistake here, but what are they trying to say? That this number is what written like this. I hope you're not getting confused. Okay, here it is 2 into 7 by 20. 2 7 by 20, mixed fraction form, right? Mixed fraction form it is, right? So like this number can be written as, or it can be written as 2 7 by 20. Mixed fraction form. So that is what proper answer you need to give. You should give the mixed fraction form if it is mixed fraction, right? So if we have seen before also some mixed fraction like here, like we should give the proper answer here. What is the answer we need to give here? We should give the mixed fraction. Means you can write 2 then 7 divided by 20 like this. Okay, let's move on. Now we have next proving irrationality of a irrational number, obviously, right? Okay, we have irrational number. So how do we prove that it is irrational number? Like suppose I say simple question, okay, root 2 is an irrational number. Prove it. Okay, so that's what. Okay, like now we need to recall the definition of rational numbers. And what is the definition of irrational numbers? If it is not, see, I said there are real numbers are divided into two categories. Either it is rational or irrational. So if it is not rational, then it has to be irrational. So if we know the definition of rational numbers, so we can say that other one is what? Okay, if it is not coming rational, then it has to be irrational numbers. So let's continue then. Okay, like let me recall. Okay, definition of, because we are going to use this, so let me say it again. Definition of rational. How do we explain, how do we define, okay, rational numbers? Rational number can be represented in p by q form. All rational numbers can be written in p by q form. Now conditions are there, where first condition, p and q are integers. Second point here, q is not equals to 0, q cannot be 0. And third point, p and q are co-prime numbers. Okay, co-prime means they don't have common factor, right? They do not have common factor, right? Now what are irrational numbers then? Irrational numbers are those numbers which cannot be represented in p by q form. Numbers which cannot be expressed in p by q form, right? Numbers which cannot be expressed in p by q form, right? That's all. Correct. So those numbers which cannot be represented in p by q form. So let's do it. Okay, now we need to do the proof of this, right? Let me take this example. Okay, given that a is a rational number, okay, let me take another page to explain it. Okay, because I want to explain you one question in detail which is given here also, but let me add the page here. Yes, I can make the duplicate of this. Yeah, so our first question, which is going to be, let me take the first question as prove that root 2 is an irrational number. We'll come to this question also later on, but let me just take this first. Right. I think we are good to go. Right. So this is what we want to prove. So what we do here, we start with the contradictory statement that we say we need to prove that root 2 is an irrational number. But what I'll say, let's say, my bad. Yeah. Let's say root 2 is a rational number. I'm assuming it to be rational number. Right. So if it is rational number, so I can write it as P by Q form, right? I can write A by B also, but okay, let me take P by Q form only because all the definition is given in that form. So let's take P by Q only. So, but we need to remember the condition where I'm rewriting the conditions, because that when you're giving the proof, okay, you should give all the points, okay, clearly there. Proofs when we write, okay, because it is subjective question and we want to get the full marks, so that's why we need to clarify all the points clearly here, where P and Q are integers. Second point, Q is not equal to 0. And third point, P and Q both are P and Q are P and Q do not have common factor. Right, this third condition is what many of the students they forget, so you need to remember this also. These all conditions should meet, right? So now this is what I have. Can I square both sides? Can I write one line here? If it is true, if this equation is true, we can square both sides by squaring both side, right? We can square both side. Now I'll get here 2, and this is P square by Q square, right? So can I write down from here P square is equals to 2Q square, right? P square is equals to 2Q square. Now can I say that P square is equals to 2? It could be like Q square is what? Okay, we can make this statement from here only, that what we can say, as P and Q both are integer, right? We are assuming that both are integers, right? So what we say here, that 2 P, so we say P square is having 2 as its factor, right? P square is having 2 as its factor, and now we understand that P is what? Integer, right? So if P is having 2 as factor, we can say sorry, P square is having 2 as its factor, then this is for sure, and this is one of the theorem, but you don't need to remember the theorem. You need to just remember that if P square is having 2 as its factor, you can take the examples also, right? Okay, then P is, or we can say must here, right? P must have 2 as its factor, right? This is what for sure. Okay, this is one of the theorem, but you don't need to remember, as I said. Okay, you don't need to worry about this. P is what? One of the integer. You can take, for example, okay, like if I have like 100 is what? 10 square, and 5 is the factor of 100, right? 5 is the factor of 100. So 10 is also, means 10 square is having 5 as factor. 5 is factor. So 10 is having 10 also have 5 as its factor, right? This is what we can say, right? This way you can remember it. You can take any number. 625 is having 625 is having what factor? 5 as a factor. So 25 root of that is also having root, in the sense, okay, if integer is there, right, integer ka square is having some factor, then that number will be having some factor. So if it is so, can I say let, as 2 is the factor of p, so can I say 2 times of m, right, where m is some integer, m is some integer, right, where m is some integer. One second. Yeah. Okay. So now in this equation number 1, here, in this equation number 1, can I substitute p as 2m here? So I need to write here by substituting in equation number 1, right? I'll be requiring next page. Okay, so I hope it is clear. So I'm just going to substitute there p as 2m. Okay, let me take this space. Okay, where should I write it further? Can I utilize this place? Right, I think right after that, okay, we have the conclusion here. So I'm going to do here, I want to write here. So by substituting here, okay, what we can write down here, 2m square is equals to 2q square. So 4m square is equals to 2q square. So can we write down here q square is equals to 2m square? Now what we conclude from here, can you come back to this statement, right, like this here? So we will write here what statement, what do we say here? We say that means q square is having factor 2. So q is having factor 2 means finally what we say, so p and q both have common factor 2, right, which contradicts our statement that root 2 is rational. So root 2 is irrational number. That's all. This is how we can conclude, right? So this is how we prove. Okay, for root 3 also we can do the same steps and similar steps and we will get the answer, right? For these numbers, root 2, root 5, like that, we can do the same way, right? So this is what it is. Now next question comes, suppose we have some rational form plus irrational form, like that, right? If it is just 3 root 2, we can start with the root 2 like this, whole squaring and all, and we'll get the common factor, like we can prove again. But 5 plus irrational part, rational part plus irrational part, how do we prove this? So we, in the question what is given to us, they are saying, okay, let me keep the annotations. Yeah, let me bring this here. So this is what our question, right? What we need to, given that root 2 is irrational, prove that 5 plus 3 root 2, given that root 2 is irrational, prove that 5 plus 3 root 2 is an irrational number. We need to prove this. is an irrational number. So what we are going to how we are going to prove it now? So as it is already given that root 2 is irrational, so can we write down, we write, okay, let us assume the contradictory, that it is rational. If it is rational, so 5 plus, if it is rational, what is given to us? Okay, we need to remember that this is already given to us. We need to write here given statement. Given is what? Root 2 is irrational, right? And you need to remember one more very important thing. Irrational number will never be equal to rational number. You need to remember this. Irrational numbers are never equal to rational number. It is never possible. Then a rational number can never be equal to rational number. So given that this is a rational number, okay, let's start. Let's assume this is rational, but we need to prove, you need to remember that we need to prove it, what it is irrational. So but we are starting with contrary, okay, that this is what, so a by b, instead of p by q we can assume a by b also, where a and b are co-prime integers, b is not equal to 0. So can we bring 5 here, right? This is what, now we did this operation, okay, a minus 5b, as we know a is integer, b is integer, so 5 times b of 4, that will be also integer, and then subtraction of two integers is always integer, right? You need to remember this is an integer, right? And down is also, this 3 also we can bring here integer, right? This is integer, numerator is integer, this is integer. So right side clearly we can say integer divided by integer, non-zero integer, right? Some integer, it is what, some integer divided by some another integer, non-zero, obviously non-zero is always, this is always a rational number. It is always rational number. But on the left side, what we have? Irrational number. And I told you irrational numbers are never equal to rational numbers. So the contradiction is because of incorrect assumption of this is rational. So that's why it is what? Irrational number. I hope it is clear. So any number of this format, which is what? Like rational plus irrational form. So we can prove it like this, right? This is how we can do it. Now we can do some more questions practice, right? Again, if I need to prove that these all questions, okay, like it's pretty easy. So I can take first the question and second one I can leave out for you to practice, okay? First question, or if you want, we have done based on root 2, we have done already. So let's take root 3. So we will write given root 3 is irrational. Given it is what, this root 3 is what, irrational. So we'll write, let's assume nine plus 3 root 3 is rational number, right? I can assume it to be rational number. So what? Now 9 plus 3 root 3 is equals to a by b form. B form here, like I did before, like we have done before also, right? A by b form, where we need to write this what, where a and b are co-prime integers, b is not equals to 0, we can write down this whole statement, right? Now 3 root 3 and a and b belongs to integers, right? Z, I'm writing in short like this, but you can write the full statement. So a by b minus 9, a by b minus 9. So we can write down root 3 to be a minus 9b divided by 3. Now we have, this is what? Rational number, because integer, but we have is this side a rational number. So it is never possible, right? As I told, irrational cannot be equal to rational. So that's why which is contradicting our assumption, right? So that's why it is what? It is not an not a 9 plus 3 root 3 is not a rational number. It is a rational number, right? You obviously need to write steps like it is given in the solution, previous solution, right? So I'm just explaining briefly. I think you can write down these steps, right? Now let's do this question. They're saying convert this to a fraction. Now I think you know that how many 3.125 divided by 1 we have. So we need to multiply 3.125 by how much we need to multiply up and down? 1000. Why 1000? Because 3 digits are there. So we can write it as 3125 divided by 1000. Now let's simplify it. Okay, we can simplify, right? Yes, so simplification can be done as, we can do by 5 6 then 5 2 5 5 and then 5 2 again we can do, right? 25 times 25 divided by 4, right? Twenty-five times yeah, my bad, it has to be 8. 25 times 25, and this is what? 8 here. So 25 divided by 8 we got, right? But we'll give the proper answer in the mixed fraction form. So 3, and then what here? 1 divided by 8, right? Like this here. 3, 1 divided by 8, right? You could have done like 3 plus 0.25, okay, like the 0.125, right? I mean to say, you could have done it like this also. Alternative method, 0.125. And now 3 plus, this is what? 1 by 8. So this is 3 1 by 8, mixed fraction form, right? Like that. This is how we do. I hope you have understood this all, right? We got, okay, again there is a slight mistake. Okay, here you need to remember it is what? 3 times 1 by 8. Yes, they have done for, okay, yes, yeah, finally it is what? Correct answer here, right? This is what we need to write the answer. You can see the steps here, right? I hope you enjoyed the session, right? Thank you. See you next in the next lecture. Thank you very much.